Hello everyone, welcome to my video. Today I'm going to show you how to do a current calibration on etracer. As I mentioned in my previous video, after a PCB is built, the full output voltage output will be calibrated against a Fluke 8808A Fluke digital multimeter. So the accuracy after calibration on spec is plus minus 0.2 volt or 2%, depending on which value is greater. So we see a calibrated voltage, and we see a known value resistor. Theoretically, we can calibrate the current by Ohm's law. So that's basically the idea of current calibration for etracer. So before we do any calibration, we need to do a offset calibration first. So the purpose of the offset calibration is to remove the offset when there's nothing connected to the HV1 and HV2, and the calibration is really simple. Okay, so we'll see two lines here. These two lines represent the measured current under when there's nothing connected to the etracer. So these two offset has to be removed to get the accurate result. So after the calibration, let's check the accuracy of the current measurement on etracer. So this file is carefully designed. So the X span from 0 volt to 500 volt, and the current span from 0 to 500 milliamp. So theoretically, if we use a very accurate 1K ohms resistor, we should measure 100 milliamp when the HV output is 100 volt, and we should measure 200 milliamp at 200 volt, and so on and so forth. So let's check the accuracy. The resistor I use is not a 1K ohms resistor. When I measure it, the value is 1004. It's 1K and 4 ohms. So for demonstration purpose, let's assume it's a 1K resistor. So now let's check the quality of the current reading before calibration. Okay, as you can see, the measured current at the high voltage region is slightly lower than the expected value. This doesn't mean that this error is actually bigger, because, as I mentioned, because the resistor I use as a reference is not good enough. So and you can also see that all the error adds up. So there is an error in the voltage output. Even after calibration, there's error in the resistor. So all this will sum to your total error of the measurement. So this is HV1. Let's check the output of HV2, and let's keep the previous curve. Okay, so you can see these two curves pretty much overlap, but still the measured data is lower than the expected value. Okay, so let's check the low current region of the current measurement. So for low current region, I use the 100K ohms resistor. This resistor is very accurate. The accuracy is 0.05%. So it's very accurate. So with this resistor, let's check how accurate are the current reading before calibration. So here I use a different file. Because the DUT is 100 ohms, so at 100 volt output I should measure 1 milliamp. And this is HV1. This is the output of the measurement of HV2. Okay, so you can see these two curves like separate a little especially at the higher current region. So this is not what we want for our. If we want to use both HV1 and HV2 simultaneously to measure a twin triad, for example, we want the behavior of HV1 and HV2 to be identical, even they have a absolute error. We still want the both output both voltage behaves the same. They match each other. Otherwise, if we use the let's say, for example, if we test one section of the twin triad with HV1 and HV2, but this kind of behavior, even we are testing the same section of the triad, will think they are not perfectly matched because of this error. But I mean, this error is actually pretty good enough, pretty good before calibration. Okay, so now let me show you how to calibrate this. So here we have a calibration button. Click on it. So as I mentioned, the calibration is separated into two regions: the high current region and the low current region. So in the high current region, we use the reference resistor is 100 k ohms. And if you don't have a very accurate 100 k ohms resistor, you can. But if you had a good quality digital multimeter, you can measure your resistance of your 100 k ohms resistor or 1 k ohm resistor and plug in the measured value here. So now let's assume we have a very accurate resistors for both values. Now let's calibrate the low current region for HV2 first. Okay, so this message box reminds you to plug in the 100 k ohms resistor. By the way, the measurement voltage here is 300 volts, so be careful, do not touch any middle part of the DUT or the test jack. Okay, now we can calibrate the HV1. Okay, and after that we can calibrate for the high current region. So here we are calibrating against a 1 k ohm resistor. HV1 first. And HV2. Okay, so if we, by default, if there is no calibration performed before the default value is 1, it means, so this is actually, the number here is the value of the measured data to the theoretical data. So this ratio is what the software needs to compensate to get to correct the reading. So before we leave, close this window, we need to apply this this setting to the system, and this button also, by clicking this button, it also saves the calibration data to a configuration file. So for future, to be used next time. So now we can exit. So now we can check the quality of the calibration. Let's reload the 1 k ohms with calibration file. and wrong. Okay, so this is the HV2. As you can see, the scale it was before calibration is lower here. Now it's much better because it's getting closer to the 300 milliamp grid. So let's check the HV1. Okay, so these two data point moves to after the correction they're closer to 300 milliamp, but you can see there's a gap between HV1 and the measurement of the current on HV1 and the current on HV2. So this is not because the calibration is not accurate. This is caused because the way etracer is designed. So the way I design etracer, I use the current measurement HV2 to decide the measurement duration in the firmware. So when we run the test measurement here, when we use the HV2 only to measure the DUT, HV1 is left open. So the firmware will measure very low current on HV1, and it will make the measurement time very long. But at this region, HV2 is outputting a lot of current. So this long duration will cause the capacitor to discharge, and the voltage will become lower. So in the firmware and software are compensating this phenomenon, but still the error here is still big. Not okay. Yeah, it's so. This is not as I said. This is not a problem actually, because when in the real use we HV1 is always the master. We also always assume the current measurement HV1 is bigger than HV2. But when we want to check the accuracy of the calibration, we can turn off the auto adjustment feature I just mentioned. So there is a switch here, auto averaging. If we disable it and run the measurement again, HV1. Sorry, I need to keep the existing curve. Okay. Never mind, the calibration it's quick. Okay, so as you can see, if we disable this auto measurement duration adjustment, the calibration result is very good. Both curves agree to each other. This region is above the capability of the current measurement. So this above 300 milliamp, the reading it doesn't matter. But below 300 milliamp, we can see the calibrated data not only match the expected value, also both curves match each other. So this calibration is done. Okay, so that's about it. I hope you enjoyed my video, and I hope we can start ship etracer in quantity in the near future. Thanks. Bye bye.